Okay, here are the three equations you need to be able to convert between all of the things we've been talking about for the last several modules. We had an energy module where we looked at the thermodynamics, and that involved delta G naughts, delta Gs. We had an equilibrium chapter where we looked at equilibrium constants. Those involved Ks, maybe Kc, maybe Kp, maybe Ksp, maybe Ka, maybe Kb. The subscript doesn't matter. And now in this module, we have the E naught value, the cell potential. And this only works for a redox reaction, but here's how we interconvert between those thermodynamic properties. These are all thermodynamic properties for a substance. So you're going to see a series of questions that ask you, given one of these, how do you calculate the other? And so, for example, you've got a type of problem that says, what is the E naught if you're given the delta G naught? And so I'm looking for the equation that includes both E naught and delta G naught, and that would be this one. And notice that I've got the listed over here. These are the R is a constant, F is a constant, T will be constant in all these problems. I won't change the temperature on you. What's not constant is N. That is the moles of electrons transferred for that particular redox reaction. So F is going to be a constant. I've got the numerical value for it there. I have to figure out N in order to plug into this calculation. And so in order to figure out N, that's how many moles of electrons are transferred. That's literally when I balance each half reaction, how many electrons do I need? And so I'm going to have to split it up into half reactions. You see a pattern here. You're getting good at that. So I'm going to do the 2 Cr plus 3 goes to 2 Cr plus 2. That's 2 plus 3's. There's a plus 6 over here. There's a plus 4 over here. That means I must need 2 electrons on the left. It looks like N equals 2. I should, until I get really good at it, I should confirm that with the other half reaction. 2Hg going to Hg2 plus 2. That looks like a plus 4 over here. There's a 0 here. Oops, it's not 2 of them. Sorry, it's an Hg2, all with the plus 2 charge. So plus 2 over here, 0 on the left. And so to balance that, I need 2 electrons on the right. These have to match. They have to be the same number of electrons because they are the same electrons. That tells me that N equals 2. It doesn't equal 4, it equals 2. So now I'm ready to plug into this equation. If I am given the delta G, and by the way, if I wasn't given a delta G, but it says use the delta G to figure out the E naught, I may have to calculate the delta G. That was in a previous module. Yes, you still have to know how to do that. But in this particular question, for my example, and by the way, don't try to figure out, it's saying what is the E naught. Don't go to the tables to figure out these two half reactions, what are their standard cell potentials. I'm taking a little educational license here to be a little flexible. I don't want the E naught that the table gives us. I want the E naught from the given delta G naught. So that's how you should calculate it, or else you're going to get it wrong. So given delta G, that is given in the problem, and in my problem it's 232 kilojoules. Again, you're not going to calculate it, it's given to you. And so I'm going to calculate E naught. If I look at that equation, E naught is equal to delta G naught, oops, that's a crummy, all over NF. I do need a minus sign because the formula has a minus sign. Let me tell you that one of the trickiest parts of these problems using these three equations is watching your minus signs. That's one of the trickiest parts. So I am ready to plug in. I do have to watch my units a little bit. This is 232 kilojoules. N is 2, and F is 96,500 joules per volts per meter. So I need to, per volts per mole, sorry. So I need to convert kilojoules to joules. There are a couple ways I can do it. I'm going to do it old school back in Chem 1, how we learned to do this conversion. There are 1,000 joules in 1 kilojoule. I could have started off by putting this number in joules, multiplying by 1,000. Again, there's lots of different ways to do that. I hope you are becoming an expert at that. Again, one of the trickiest parts of this is to remember your minus sign. So my answer is negative 232 divided by 2 divided by 96,500 times 1,000. My value is 1, 2, and it's usually going to give me some guidance on significant figures, just so we all get it right. And it says to go to volts to 2 decimal places. So I'll call that negative 0.12 volts. A good thing to double check, and these formulas are in your textbook right below a table that talks about whether or not it's spontaneous. This means it's spontaneous. And I'm sorry, this means it's not spontaneous. And E naught, that is negative, is not spontaneous. That should agree with the delta G that's given. Delta G naught that is positive is not spontaneous. That is a good double check to help you from making a mistake with your signs. And that's one of the trickiest parts of this calculation. So not spontaneous. And it looks like I've done, hang on, it's your job to double check my math every single time. And it looks like I may have made a math mistake. So let me do one thing. Yep, I made a math mistake. My decimal's in the wrong place. So 1.20 going to 2 decimal places. Double check my math always, but I caught it this time.